In this example, we're going to be doing exactly what we said at the end of the last video. We're going to find a couple of vector projections. So here's a couple of vectors in R3. We've got the vector u, which is 5, 1, 3, and the vector v, which is 1, negative 2, 4. So the formulas that we're going to be making use of, the vector projection of v onto u, we said in the last example, is u dot v divided by u dot u, or the magnitude of u squared, times the vector u. Now, similarly, if I were to reverse the role of u and v and do the vector projection of u onto v, essentially just write everything with v in place of u and u in place of v. Biggest way to remember how to keep these straight is whatever vector we're projecting onto, we should be going in that direction. So vector projection of v onto u should end with a u. U onto v should end with a v. So we're going to need some dot products. So first off, the dot product of u and v is going to be equal to, we multiply the corresponding components together, we get 5 times 1, plus 1 times negative 2, plus 3 times 4. That is 5 minus 2, that's 3, plus 12 is 15. Additionally, we'll need a couple of norms squared, or dotting these vectors with themselves. So that'll be 5 squared plus 1 squared plus 3 squared, which is 35. And we'll need v dotted with v as well. So that'll be 1 squared plus negative 2 squared plus 4 squared, which is 21. Now, with those things in mind, there's an interesting trio. This one's 3 times 5, 3 times 7, 7 times 5. Makes a nice little round robin there. Not intended, unless you were impressed by it, in which case it was totally on purpose. Most definitely. So, projection of v onto u is equal to the dot product of u and v, which we said is 15, divided by the dot product of u with itself, which is 35. We can reduce that fraction, multiplied by the vector u. So multiplied by 5, 1, 3. Now what I'm going to do is reduce this fraction down so that it's 3/7, and then distribute it through for each of these components. So 3/7 times 5, we get 15/7. 3/7 times 1, we get 3/7. And 3/7 times 3, we get 9/7. This would be the vector projection of v onto u. Next, we'll do the same thing. We'll just reverse the role of v and u and do the projection of u onto v. So for the vector projection of u onto v, this is going to be equal to the dot product, 15, divided by dot product of v with v, that's 21, times the vector v. So 1, negative 2, 4. Like we did for our other projection, we are able to reduce this fraction, so we do so. Call it 5/7. And we distribute the 5/7 through to each of the components. So that'll be 5/7 times 1, 5/7 times negative 2, that's negative 10/7, and 5/7 times 4, that'll be 20/7. All right, hope this was helpful, and we'll do some more examples later.